Thank you. As I said, my name is Maurice Falvey, and I'm a mechanical engineer. And what we're about to talk is about a project in County Kerry, which is a certified passive house. The homeowner typically would have been used to living in Irish standard houses. They would have been spending £2,500 to £3,000 in Isle a year. So they approached ourselves and an architect about building a passive house. Now, passive house is a concept that most of us are familiar with, but none of us really knew the detail. So what we actually tried to achieve was a learning curve for all of us, and a very, I would say, enthusiastic client. If we just look at the house itself, it's a very traditional type of house design. They're very much into their gardening, so they live at home. We achieved the plaque early on this year, and also you'll see that from the gardening point of view, this is an orchid for anybody that's not used to looking at various plants, but that's what it is, I was told. And they used the passive house for germination, so that was an interesting output. The house itself, we were talking about BERs, it's achieved an A2, but you consider for a passive and low energy building that would be much better. But in reality, there are certain things in passive house that are not really taken care of in deep, like thermal bridging and all those advanced building techniques, which this is a thermal bridge free design. Now what's interesting, looking at the numbers point of view, we're actually talking about 8 watts a square meter. For any engineers in there would think, oh, that's so low. That's a peak load in the worst case scenario. Whereas maybe in traditional Irish houses, even today's standard could be 30 watts. So we're way, way down on that. And other things like the overall consumable energies used by the building, because in passive standard buildings, you take into account the energy usage for everything, including your washing machine, dryers. But one of the focuses that we wanted here was to build a very comfortable house as well. We didn't want to insulate the living daylights out of it and being unlivable. So that's what the plaque looks like. It's in an exposed site in County Kerry, so plenty of wind energy there, but that's actually the Gap at Dunlow for people that might be familiar. The house is treated floor area, which is close to 180 square meters. You can see the U values exceptionally well below the current Irish building standards. The triple glazed windows, and the air tightness was one of the biggest criterias of any house that you build for passive. You can see there's two test methods, the N50 and the Q50. We won't go into too much details, but you can see we've achieved 0.56, which is a good result. It's below the threshold of 0.6. But if you look at an Irish standard, we were actually 0.02. Exceptionally good. Exceptionally good. And this is quite good achievement for a bunch of novices that had never built a passive house. I remember the homeowner who obviously read the script. We did the PHPP, and the first thing he picked up on was air tightness. And the first meeting we had with the contractor was, any one of you with Stanley knives, hand them up now. And he removed them from their possession. One thing, when you look at the types of outputs, what we were doing, we were using a compact type heat pump, which I explained earlier, and we were talking about a 2 kilowatt output from a geothermal, 2 kilowatts. Thank God no stove, because it would have screwed my results up. I didn't want to have a log of everything that they used, so we persuaded them not to put in a stove. I may have sounded that I had other motivations, but he actually didn't want one himself, so that was an easy task. We put in some solar. We'll look at it earlier on, because as far as I was concerned, solar wasn't really a necessity, and I'll explain later on. It was for compliance purposes. The first task that we had to try and achieve is create a good indoor climate. And ventilation is a big part of it. There's a minimum requirement in Passive House for 30 cubic meters of air per person, equating to about 0.3 air changes an hour. So we had to try to achieve that as a minimum. We wanted to keep a threshold of about over 50 to 55% in relative humidity, so we were monitoring that. And we also wanted to maintain the ability to heat by air. That was one thing. So you'll see no radiators, but there was on-the-floor heating put in certain places. You can see here we had a main distribution manifold in the floor. We sandwiched the ducting between 2 layers of insulation, and the boxes were actually, we were delivering air, ventilated air at floor level, but we put them at the floor because we were also delivering the heat by, at floor level, so obviously it will actually rise and extract at ceiling level. One thing that you'll notice here, this is the box out of the extract, so we'll see nothing in the house, but one thing that you'll notice, this is the extract being up inside the stud wall. One of the other reasons is the air tightness envelope. When you do a passive standard building, the first thing you've got to consider is, where's my air tightness envelope? And that is your threshold. You keep within that, you protect that in every way you are when you're constructing. But you can see the taping. Okay. If you drove past this house, you wouldn't even think it was passive. You just think that the guy was enthusiastic about glass. It is southern face. One criteria, without going into any passive and low energy buildings, is that it's actually insulated right down into the foundation. You remove any thermal bridge. Now you think down in Kerry we don't see too much cold weather that we create permafrost. But we applied all the passive principles anyway. You can see the air tightness. We created service cavities so that the air tightness membrane is maintained at all points. We backfilled and concreted around these and sealed them once we finished. Well, what have we got? Well, that's just a little cutaway of the ducts, what the final product would look like. That's actually on the floor. Not that I'm a crap photographer, I got my shoes into it, so they actually see it was on the floor, and this was actually on the wall. And we could control the ventilation that way. The unit itself was a compact type design. The supply and extract are actually in the floor on this particular instance. The little laptop monitoring is sitting there at the top. So contained within the system itself, it contains a hot water cylinder. It contains a passive recovery unit that you'd see in an attic. It contains an air-to-air heat pump. And here on the side, we've got a little geothermal module that has a ground source collector outside. The idea is that we would take ventilation. The passive house has so much internal gains. It has very little leakage. It captures everything from solar radiation to internal heating gains. The idea of the system is that we would capture and produce everything we can from that. So we were able to take the air coming in, and we were able to move it through a passive recovery unit. We were able to heat it, and we were also able to use the same exhaust energy to produce hot water, and the geothermal was only ever used in a backup situation. And because we didn't have a stove, and of course I could monitor it as well, which made life easy. That's what it physically would look like. Now the operation of it. The operation of the system is completely automatic. You're not flicking switches to go from a summer bypass mode that you see here to a passive recovery mode to an active heating mode. So, for example, if we have a very pleasant summer day, plenty of internal gains anyway, all we're doing is we're taking the exhaust energy from within the building and we're going through the heat recovery unit and out. The fresh air is coming in, it's bypassing the heat recovery and it's delivering into the house. So we've got ventilation taking place at that particular point. So there is no heating taking place. In another mode, if the temperature is dropping down, so at this stage we're only running 35 watt fans. So if it drops down to around 5 degrees, we were able to take that exhaust air going through the heat recovery, but also preheating the fresh air coming in. So we had capture the energy wherever we could. And if the temperature started dropping down more, we were still using the passive heat recovery system, but we're also now bringing on a very small 300-watt compressor to deliver 2 watts of heating. So we're actually now delivering air and energy from what's been already recovered. So we could take that fresh air from 0 degrees through the heat recovery, bring it up to 20, and then through the actual heating and bring it back up to around 38 degrees with a 300-watt fan. At the same token, we were using the hot gases from the system to produce the hot water, and we could bring that over 55 degrees. So we're still using the exhaust air from within the building. Luckily, the machine had internal sensors built into it. It was used by the R&D department at Neelan. So there's a USB port, and all I did is just hooked in a laptop. And Seamus, we collected something about 15 million measuring points out of one machine in the year. So we're heading now towards your target. Out of one house. So we were recording every minute of every day. So every sensor had about 45,000 measuring points per month, approximately. So we knew everything that was going on in that house. And we could measure. So we were able to measure fresh air intakes, what the efficiency of the counterflow heat recovery unit, what the temperature after the condenser heater, what was the evaporation temperature coming out, and we had many more. We could check the sensors in the hot water cylinder. We had a relative humidity sensor, and we had an internal sensor in the living room. The internal sensor in the living room was governing the control of this machine up here. That was situated in there. That's what the controller would. From a client's operation point of view, all they had to do was set a temperature and set a ventilation rate. And if there was a higher humidity level, the boost rates would come on the machine and control the ventilation rate and increase it to reduce the humidity levels. So it was completely automated. I've just put this up, but I'm not going to ponder too long on it. It's a bit of a hard thing for SEAI to get their head around, to be honest, because within the same machine, because we had to get the BER completed for it, within the machine we had a passive heat recovery, we had an air-to-air heat pump, we had an air-to-water for producing hot water, and we had a geothermal unit all in the one box. How many pigeonholes do you want to fill? So when I went to SEAI and they said, what have you got? Well, I have all of these. We don't have a box for that. So we come to a compromise. So I've got some of Appendix Q in there. I have some HARP in there. I have some data that they haven't used before. So we created a document just to shoehorn it into deep. And there were some of the COPs. Now, for people that are interested in heat pumps in general, and especially air-to-air, just be careful that the temperatures that this was tested, this compact was tested with external air. And the reason is, I'll just flick back. The reason why it's going with external air is that it is actually utilizing first the energy through the counterflow heat exchanger, so the air temperature is actually significantly reduced. So we can't just say that we're taking 20 degrees out. In fact, actually we're not. The counterflow heat recovery is removing some of that energy. So we're using test data from +7, +2 down to -7, and these are some of the efficiencies, okay? And the efficiencies for hot water, which are low, but in reality, it's taken the exhaust air. This is just an overview of the building. I just took the architect's sketch and I superimposed my ducts onto it. Just gives you an idea of the layout. I'm still a traditionalist. I always like to put radiators near to windows, even though Dansteg says you can put them there. But I try to use this psychology, even though I'm an amateur. If somebody reaches to open a window in a passive house, at least they might feel the air coming up and it might stop them. But it's not a criminal offence to open a window in a passive house. The unit itself, okay, very quickly, there it is. There's the geothermal. We put in solar as a preheat. There's the geothermal connected to the underfloor heating. And I have some values for what we gain from solar. One argument I would say about the solar was that the compact heat pump has nothing else to do over the summer period other than make hot water. So he had 180, he had 300 here, so 480 litres of hot water for 3 people. Bit too much. All right, the interesting thing was, for a complete year of operation, we maintained 20 degrees within the house, all year round. What do? We had our air-to-air is mapping along here, and you can see there's the external temperatures. So the heat pump will react positively to a negative drop in temperature. What happens here, I've just took November. What's interesting here, this is the green line, which is the internal temperatures, the blue is the external, and the red is the little jumps above is where the active heating took place. Here is where anything below the green line was a passive recovery. But what was interesting here at this particular junction is within that few days, no heating took place, and it's in the middle of November. And I talked to an architect called John Moorhead, who's very much into climate data, and he said, check out the Valencia weather station. So in fact, actually, over those days, we had 3.5 hours of direct sunshine, and that was sufficient enough to heat the house without any active heating taking place. All right, very quickly, what did the data actually prove? It proved that the bypass unit, over a whole year's period, so 46% of the year, the bypass valve was open. There wasn't even heat recovery taking place. It was just ventilating. Out of the whole year, only 14% of the time in that building, there was actually active heating being used from the heat pump. And what I've got here is a mapping of the temperature. So you can see the red. The red is indicating to the cold, to the amount of heat pump usage, and you can see it's mapping as the temperature gets colder and then drops off as it gets warm. And you can see here with the bypass valves, it's obviously open, closed during the winter time, and then it opens. So what we're doing is we're taking the ventilation and we're controlling the air flow into the building and utilizing the energy to balance it. I'm not going to spend too much time more on it. There's the relative humidity. We're able to maintain it between 50 and 60. The hot water, because anytime you turn a tap, it was producing hot water, so we were able to keep an average of 50 to 55 degrees plus. Well, what does the whole system cost? Well, we are able to tell every hour of anything that was running from the heat pump operation time, what the geothermal was using, and if I look to the brass tacks of it, we can see that to run the compact heat pump on its own cost 120, nearly 130 euros. The underfloor heating side of it, of course in the compact you had air-to-air heating and you had geothermal, and that energy use was 206 euros. So I included even the fan power. Actually, before I go away from that, I got a bit upset because the pump was actually using a bit more energy than it should. I think he was disgusted he didn't have to use it because he paid so much for it. So he left it on, and it was unnecessary. Overall, we used about 220 euros for all the heating and hot water for the building to maintain it at 20 degrees for a year. And predominantly ventilation. You'd have an argument. He spent, okay, if you look at the geothermal usage, it wasn't the whole pile. It was actually 76 euros. He spent about 5 grand on that. He could have put a stove in, be a lot cheaper. Okay, we wouldn't have been able to monitor it very well, but he was happy out. So the underfloor heating only came on in the hallway, nowhere else. He didn't need it. How do we stack up on passive house? This is my main criteria because I just wanted to see did passive house actually work. One of the criteria that was interesting to me as an engineer is what was my mechanical system, how did it work? Well, I had calculated out, which was the primary energy value of 50. That'd be kilowatt hours per square meter per year. In fact, actually, what we calculated from the PHPP was around the same figure. So I think Dr. Wolfgang Feist wasn't really lying to us. It actually does work. So what was the positives from this? Well, we learned a lot. We know that passive house does work in our temperate climate. It doesn't necessarily have to be a fantastic glass facade of a house. You can build a standard bungalow, face it south, be very clever on your air tightness and insulation, and it's very doable. And out of this, we're now onto our third passive house in Kerry. The other one will be certified. They're springing up around Cork. We've been approached now to look at doing some manufacturing of a passive certified unit and generate some employment in Ireland rather than keep importing the technology. So, and there's other markets for that sort of knowledge base abroad, and that's what we're hoping to utilise. Anyway, thanks for listening.